Hi, I'm Bridget Bermeo, and I'm going to discuss graph coloring for planning today. Now, before I get to the planning part, I'd like to first explain what is graph coloring. So graph coloring is from the graph theory, wherein we color the vertex in such a way that the vertices joined by an edge have different colors. So this line here, this point here, is the first rule of graph coloring. Now here we can see is an example of a graph, and these circles or these dots are what we call a vertex, and the line that connects two vertices is called an edge. Now, aside from this rule, we have another term to consider, which is the chromatic number. This is the least number of colors needed in a graph. It's identified by counting the number of colors in a graph with the least used number of colors. So this is our second rule, is that we have to make sure we use the least number of colors in coloring a graph. So here's an example of a colored graph, and it's already colored in. Can you tell me what is the chromatic number? We can simply do that by counting the number of colors inside this graph. So 1, 2, 3, 4, and 5. The chromatic number of this graph is 5, since it used 5 colors. So how do we actually go about coloring a graph? Well, it's quite simple. There are 3 steps, and it's really just step 1 repeated. So step 1, find the vertex with the highest degree and color. What do I mean by highest degree? The highest degree refers to the vertex with the highest number of edges connected to it. So if we look at vertex 2, we can notice that it has 5 edges connected to it. And we'll see that this is one of the vertices with the highest degree. We'll also notice that vertex 5 also has 5 edges connected with other vertices. So 1, 2, 3, 4, 5. So you might now be wondering, so which vertex should I go with first, since they're both equally with the same degree? Well, it's quite simple. Simply choose whichever you would like. So I chose vertex 2, colored it red, and then I was able to color vertex 7 and vertex 8 as red. This is because they are non-adjacent to vertex 2. There is no edge connecting them, no edge connecting vertex 8 to vertex 2. You might be wondering, why didn't I color vertex 9 since it's non-adjacent to vertex 2? Well, that's quite simple. If I colored red, then it would now be adjacent to vertex 8, which is a red vertex. So moving on, we go to the second step, which is again repeating this and choosing the vertex with the highest degree again. So this is the time for vertex 5 to shine, since it has 5 connected edges. So this is where we last left off, and then I start to color vertex 5 green, and then vertex 4 and vertex 3 green as well, since they are non-adjacent or unconnected vertices. And then we move to step 3, which is repeat until we are done. Repeat the process of step 1 until the whole graph is colored. So this is where we left off, and I went ahead and colored the graphs. Because vertex 1 is connected to a red and a green vertex, I had to start with a new color, which is blue. I was able to color vertex 6 blue as well, since it is non-adjacent to vertex 1. But on vertex 9, I had to go with a new color, as it's connected to a blue vertex, a green vertex, and a red vertex. So now, what is the chromatic number of this graph? We count again. 1, 2, 3, 4. We have a chromatic number 4. So you might be wondering, what are the actual applications of coloring a graph? Is it simply just fun? Is it just a coloring game? You might be surprised to find that it actually has multiple applications in various fields. It can be used for making a schedule, mobile radio frequency assignment, Sudoku, register allocation, bipartite graphs, and map coloring. It has all these applications because it addresses contentions and conflicts, ensuring that there are no clashes between two things. So there's different kind of discussions we can tackle on graph coloring, but today we are going to focus only on making a schedule or a timetable, specifically planning. So now, you might be wondering, how are we going to actually use graph coloring in planning? Well, we're going to first see what is our given. So in planning, we have a set of events. These are the things that you have to do. These are the things you have to get to. These are lectures, classes, exercise sessions, or routines. Activities, basically. And together with these set of events are a set of time slots. These are the space or time we have to do these events. So it can be denoted by a date, a day, and a specific time, and so on. So our task now is to assign the events to time slots in accordance with a set of constraints. So what do I mean by constraints? These are the criteria or limitations of certain events or individuals involved in the planning. An omnipresent and inevitable constraint is the event clash constraint. This states that no one person or single resource can attend two events happening at the same time. This is simply because we can't be at two different locations at the same time. Aside from that, we have to ensure, looking back, we're calling to the second rule of graph coloring, is that we have to keep the number of colors no larger than the number of available time slots. This is because if we have too many colors and not enough we have too many colors that go beyond the number of time slots, we would no longer have any time. Okay? So in translating graph coloring, in translating planning into graph coloring, we have to consider each event as a vertex, and then the edges between any vertex pair that is representative of the contention or possibility of constraint between two events. So this means when two events can happen at the same time. So, and then we consider each time slot as a color. So this may be confusing now, as this is all words and seem abstract. Let's make it more concrete with an example. Graph coloring for enlistment. I chose this as a topic because as a college student, I find enlistment quite confusing and can be tedious. So with graph coloring, we put a system for planning your enlistment. So I've made 6 steps, and although they seem quite a lot, they're all very simple. Step 1 is to identify the slots, or what are the available time slots for each class. We have to organize, assign a color for each slot, plot out the graph, begin coloring, and review and revise. So step 1, identify available slots. So I made this very simple and very small example with only 3 subjects. We consider every subject as an event, as they are going to be your classes. So every event here is considered as a vertex. So we have 3 vertices. Now, underneath each event or each subject are time slots to the class. These time slots will be considered as our time, or as the colors in the graph. Now that we have identified the slots, we will move on to organizing and filtering. This is when we create the constraints and the criteria we will use in choosing the time slots. So here is a example criteria that you may use in the future, but since we are using a very simple example, I will only be fulfilling the first criteria, or answering the first criteria. So we will limit our choices of time slots to afternoon. So going back to the table a while ago, we will start to cross out all of the slots that are not in the PM or every class's morning class. So it's all crossed out. Now moving to the next step, which is assigning colors. Here's the table all cleaned out, all now in the afternoon. And we can create this time slot representing every time slot with an assigned color. Now these colors are, you can change them up to any color that you want. I've only chosen this as an example. Now, you might be wondering, why is 11 to 12:30 different from this 11 to 12:30? Simply because the days are different. Instead of Tuesday and Thursday, this is Monday and Wednesday. Okay, so now that we have assigned colors, we can begin plotting out the graph. So going back, here we have our color table, just so it's clear. And creating a graph, first we identify the vertices, which are the classes. Since we have 3 subjects, we have 3 vertices. So 3 vertices. And now, in creating the edges between connecting these vertices will depend on how many or which events have coinciding time slots. And now we can do this very simply, as we colored all of the time slots to which are similar, to which are identical. So here we can see that art appreciation, history, and statistics have the same, identical time slots, not just one, but multiple, if you look at it. So our graph will look a lot like this, exactly like this. And now that we have a graph, we can begin coloring it. Since we have a very simple graph, we will not have any issues in fulfilling the first rule, which is ensuring that the colors of adjacent vertices are different, and the second rule, that ensuring that we use the least possible amount of colors. So seeing here, we have 3 different colors, so that is our chromatic number, 3, and then we see that none of them are repeating, considering that they're all connected. So now that we have our graph, we can now create the timetable. Here in the timetable, we can see the events and the connected time slot to it. Although this is just an example, you can change up your timetable to any aesthetic format you would like. I've only made mine like this to keep it simple to see it right away. You can change yours to any way you would like, so long as the event is present and its corresponding time is there. So now that you've made your graph and made your plan, you now have a completed enlistment schedule. But since planning and making a schedule is very personal and a subjective process, you may want to review and reassess your decision. Sometimes, although we may create criteria and constraints early on, you might find later on when you're finally done that you don't like the timetable you've created. Maybe you find it's too rigid or too overbearing. So you may review it and see what you could change. So going back, here's our timetable currently. You might start to think, maybe I don't want my statistics class to be this early because you're going to feel groggy. Maybe you don't want your art appreciation class to be this early because you want it to be at a later time to better appreciate it. And maybe in history, you love this schedule, you love this time, but you're okay to change Tuesday and Thursday days to something else. So you can now revise it to look a lot like this. So statistics can now be at 12:45 to 2:15 on Tuesday and Thursday, exchanging with your previous history class schedule. So that allows your history class schedule to now move to Monday and Wednesday, but still retaining the same time. And in art appreciation, you move it to a much later time slot. And then your graph can look like this now, still following the rule, the first rule and the second rule of graph coloring. So this is a simple example, and it doesn't exactly represent reality, as it takes only 3 subjects, when most of us take maybe 5 to 8 subjects in a term. So this is just simply to know the process. So when you plan your own, here are some basic principles for planning using graph coloring that you should remember. Remember that each event is represented by a vertex, and that any constraints, any possible contentions between any event or vertex will be represented by an edge between these 2 events, and that each time slot corresponds to a certain color. So, you're on your way to creating more systemic planning with graph coloring. Thank you for watching and listening. If you want to learn more about graph coloring, you may check out these references I use in my own PowerPoint.